Alright, now I want to look at directional derivative. And the first derivative we are going to look at now is to look for the derivative of the gradient of phi. This is grad phi. For example, let's say if phi is equals to s square y cube and z cube. Evaluate the phi over dx. What will be the phi over dx? That's what we want to look at now. Now, this means that the partial derivative of phi with respect to s, that's the meaning of this. So we are going to differentiate this one partially with respect to x. That means you differentiate only the x out and leave the rest. Remember how to differentiate something like this. S square. Differentiate s square, you're going to have what? You're going to have 2x. I mean, yeah. Then the rest remain the same. Y cube and what? And z cube. So I'm going to have 2s y cube and z cube. That's what we're going to have. 2s y cube and z cube. Let's say we have this other question. If phi, let's say if phi is equals to s square y cube and z4. What is the phi? What is the phi over dx? So I'm going to do this one now. The same thing. Partially differentiate phi with respect to x. This means this is what we call phi. Because that's phi in the Greek alphabet. So if you differentiate this s out, now what I'm going to have? I'm going to have 2x. The rest remain the same, which is y cube z4. It's as simple as that. So let's say we have this. If phi is equals to s square y cube z4. What is the phi over dy? What will be the phi over what? Over dy. In this case now, we'll differentiate only the y out. But we are partially differentiating phi with respect to what? With respect to y. That's how to do it. This symbol means partial differentiation. That's the meaning of that symbol. Differentiate phi partially. That is, differentiate only this variable in this downside out. Differentiate only this one out. Differentiate that as y cube. We're going to have 3y square. So that 3 is going to be outside. We're going to have 3y. Remove 3 and 1 from 3. We're going to have 3y square. Then there's z4. Take note of this. We're going to have 3y square. If you differentiate y cube, you have 3y square. So that 3 will come outside. So we're going to have 3s square, y square, z4. That's what we're going to have. So let's say we have this. If y is equals to s square, y cube, then z4. What is the phi over the z? What will be the phi over the z? That means we are going to differentiate only z out. Only this z out. Differentiate z raised to power 4. What are you going to have? You're going to have 4z raised to power 3. Remember, you use this 4 to multiply z, then you remove 1 from 4. That's how to differentiate. Remember that. So differentiating this z now, we're going to have 4z cubed. So that 4 will come outside. That 4 is going to come out. The rest will remain the same. Then z will not be what? Z will not be cubed. So we're going to have 4s square y cube z cube. That's going to be the answer to that. So this is just the introduction to this partial derivative. So let's look at this simple question. Let's look at this simple question. The question is for us to find the what is it called? It's for us to find all right, let's look at this. To find the vector in the direction of the resultant of find the unit vector in the direction of the resultant of P equal to 5i plus 3j. Then the Q is equals to 7i minus 8j. Then says you find the unit vector in the direction of the resultant of these two. So the resultant of the two is when you add both of them together. The total of the two is the total. Add the two of them together. So let's add the two of them together to see what we're going to have. We have 5i plus 3j. Because space, let me just forget about writing. What you just have to do, just add this I to this I, and you work this j to this j. So 5 plus 7, that gives us 12. Alright. Then what about 3 plus minus 8? That's 3 minus 8, that gives us minus 5j. Minus 5j. So what is it called? The unit vector now in the direction of this resultant, something like this, is the vector, the resultant vector divided by the magnitude of that resultant, which is the resultant is 12i minus 5j. Then what is the magnitude? We did this one in our first class. The magnitude is 12 squared. I told you for magnitude, even though this one is minus, you put plus 5 squared. That is for magnitude. So if you do that, what are you going to have? 12 squared plus 5 squared. What is that? That will give us something very nice. That will give us 13. So we are going to have something. The final answer will be, the final answer is going to be, the final answer is going to be our unit vector in direction of the resultant now will be 12i minus 5j over 13, or 12i over 13 minus 5j over 13. That's still very, very correct. That will be the answer to that question. Now let's look at this question. Question is to find the magnitude of the resultant of the velocities or of the following vectors. The first vector is P, which is equals to 5i plus 3j. Second vector is Q, is equal to 5i plus j. And the third vector is R, which is equals to minus 3i plus 4j. And the resultant will be the addition of everything, the total of the, that means if you add P plus Q plus R, that will be the resultant. That is the addition of everything. So let's add now to see what we are going to have. Let's add to see what we're going to have. We're going to have this plus this. Just add all the I together, then add all the J's together so that you'll be very fast. So 5 plus 5, that is going to give us 5i plus 5i, that is 10i. 10i minus 3i, that gives us 7i. Then let's go to the j. 3 plus 1j, that is 3j plus 1j, that is 4j. 4j plus 4j, that is plus 8j. Plus 8j. Now to find the resultant of that, to find the magnitude of that resultant now, just take the square root of 7 squared plus 8 squared. Like what we did before. Resultant means you take the square root of the quotient of I squared plus quotient of j squared, whether it's negative or the thing is positive. So if you find the square root of 7 squared plus 8 squared, you're going to have the square root of 133. That's what you're going to have.